So I'm at Ahrens, work at Delphix. This is George Wilson. We're from the original ZFS team at Sun/Oracle.
OC.
Yay!
Yeah. And so we wanted to talk about the potential ZFS dtrace provider, which we are proposing for the first time here. So far, this is only slideware and ideaware, so we'd like to solicit you guys' input on what you would like to see from the ZFS dtrace provider and what kinds of problems you want to solve with it and how we can provide the right information to solve those problems. So we have a couple of ideas about what what sort of different probes would be useful. So first of all, kind of the most glaring omission is that the existing I/O provider traces all the I/Os that happen, but it doesn't give you any information about the file or file system that those accesses are happening to from ZFS. So it works great for UFS, but not so great for ZFS. So I think the first step is to get that working, and this would work only for like normal I/Os, so not metadata I/Os, not ZIL I/Os, stuff like that, because it's hard to like associate, like what file are we going to associate with that. The most simplistic implementation would only provide this information for reads. I think that's kind of like the first thing that we would want to do. After that, we want to get it working for writes. So the tricky thing about writes is that the writes generally don't happen in the stack of the guy who's actually doing the write system call. The write IOs are generated from the sync thread, which is several seconds later from another thread. So it's harder to associate which file they're talking about at that time. So we'll need to like save more information away in ZFS so that we can know what file it was. So in particular, like the I/O provider today, the way that it works is you attach a vnode T to the buff T, which is passed to the I/O strategy.
So Matt, that dovetails nicely with another conversation that I wanted to have, which is this whole synchronicity. How do you get from there to there? And
Yeah.
how these two together? It
Yeah.
happens in other places in the system, not just DFS.
Yeah. So we probably don't want to just attach that vnode because the thread could have exited. It could have dropped the closed the file descriptor, and then the vnode could go away. So we'd have to either like hold that vnode for the whole time just for the sake of the probe, or we would copy the data out of it. So basically copy the v path into a ZFS specific data structure, which we would know would be present until the data gets written out. So I think getting to well, let's get to the asynchrony.
Quick question though, like if that were done just for the I/O provider, I mean, and maybe Brendan can answer this, would that be useful information for people that have been like looking at ZFS I/Os today?
Yes.
Seems like without the writes though, it's incredibly.
Yeah, the writes definitely are a challenge.
It's totally just less than half of the answer. Great.
Right.
Next steps would be obviously to make the I/O provider provide the information about files for writes as well. But in our experience, there's so many different kinds of I/Os and different ways the I/Os are generated from ZFS that even just having the reads and writes and which files they're associated with is oftentimes not sufficient to understand what's going on with the system and why those reads or writes are being generated. Some of the I/Os, like I said, we really can't associate with a particular file because, for example, they're aggregated I/Os where we're doing writes to several different files, and we've aggregated that into one I/O to the disk device, and then pieced together the data from many files too. So we would need we're thinking about doing something like a ZIO provider or probes for ZIOs, which would provide ZFS specific information, and probably add a layer information about not necessarily the physical I/Os, but like one layer above that, which would be like the ZIOs. So when ZIOs get created, you might have, for example, several ZIOs that get aggregated into one physical I/O, or you might have one logical ZIO, which gets broken apart into many physical I/Os. For example, in the case of mirroring or RAID-Z, where one logical write needs to get broken up and write to several disks.
So the scattered data problem again is a classic problem with the networking stack as an example, right? You get one NFS off and it gets broken up into packets, or then you got LSL, which throws another register.
Yeah, so I think the idea would be to conceptually have the ZIO provider tell you about these IOs get generated, and then be able to correlate that with the IO provider, so that perhaps the IO provider could get an additional piece of information, which is which ZIO is this associated with.
So the other thing that will be really interesting is insight into the ZIO pipeline.
That's
Yeah.
exactly
Pipeline
right.
is very poor, and the other thing that kills us on is metadata. I frankly, I could spend weeks generating metadata input. I'd like to see every operation transacted for the metadata.
Yeah.
If you work with any large deduplication workloads, it absolutely kills you in ZFS.
Yeah.
To not have insight into that process.
Yeah, and definitely this is something that you would be able to tease apart, whether you just want to look at metadata, combination of both.
So the whole of the IO pipeline, the ZIO pipeline, definitely.
Yeah.
But metadata is very, very specific.
Mm-hmm. So there's kind of, I think, two things that you're referencing there. One is the pipeline, in other words, the stages of that ZI goes through. In other words, like allocation, compression, deduplication, and then finally down to the actual physical write. And the other is differentiating this IO is this particular type of metadata. Like this is the IO for we're reading a space map, or we're writing a part of the dedupe table, or we're reading an indirect block. So that kind of falls.
So imagine, I'm imagining here that you could have when you create a ZIO, top level, create a new timestamp, whatever, an identifier, right? HR time keys would be good enough, right? If you were to pass that through the whole stack, keep it all the way down to the IO provider, right? I can go from the, if I go from the IO provider, this IO was associated back with this ZIO, and I can see even multiple of them into the aggregates if I need to, or whatever, right?
Yeah.
That would be full visibility, right?
Yeah.
I need that reference, for lack of a better term, to be carried all the way through.
Yeah. So I think having that tag go from the ZIO to the IO, physical IO, would be great. I think even better would be being able to have that go even from higher up the stack.
Right.
So that you could have, for example, even the application be able to say, oh, like I'm the Oracle database. I'm doing this on behalf of this SQL request number 78, and then have that get tagged down through all of the system calls and the IOs. So you could then say, oh, this SQL query resulted in these 100 ZIOs and these 150 physical IOs.
I think you saw the example of this today with Theo's example earlier on, where you actually saw the breakdown occurring of where you were in each one of the stages.
Yeah.
Where we were in the pipeline, how much time, how many actions, what transactions were there, being able to trace one from cradle to grave with a scatter gather.
Yeah.
So I can see one problem with that though. If you start way up high, really high, right, all the way up in the application layer, and that's going to generate perhaps 100 or 1,000 or 1,000,000 ZIOs, my ability to go back and find anything in this massive data is going to be really hard, right? Because I've only got one tag. So I'm inclined to think is I think about me looking at the system. At the point of the ZIO, being able to take the tag report, if I have a tag from an application, let's say, and say, okay, that's this ZIO, I'm going to generate a new tag, right? I'm not going to pass through the same Oracle tag. But at the point of that provider, I can have both tags. So now I can correlate them in my decode if that's what I want to do.
So both tags meaning the tag from the application
The
and
tag from the application is a
the
new one that I'm
ZIO.
going to pass down, right?
Before we get kind of too far off the rails on, I mean, I think that in any given system that has asynchrony, it's important that we've got tags that we're able to propagate up and down.
Yeah.
I think that you've got to assume that at the point of egress, at the point of ingress in that system, that you've got someone else going to associate that. I mean, leave it to someone who's instrumenting the database to figure. In many of these, for example, like the thread is actually sufficient context. So I would say focus on the asynchrony
Well, I think
only
that
in the ZIO pipeline.
yeah. So I think that the problem with that is that for writes, we don't have it's very hard for
You can't use the thread, for example.
You can't use the thread.
No, you
right?
clearly need to
So-
have a different ID that moves all the way down.
Yeah.
But if I want to mate that to broader context, let me mate that at there is a point of ingress into that system, right? There is a point of ingress into the ZIO pipeline where my context is my true context, and let me then mate that to the tag, and then watch the tag all the way down.
The problem is that it's not actually into the ZIO pipeline. It could be, it's into the system call. So like, the application does a write system call, no ZIOs are generated.
Right.
All that we've done is like dirty some data in memory.
Yes.
So I think that that's the tricky part, is how do we associate that to the ZIO, which eventually gets generated. Like we could save like the thread T that dirtied the data and then give you the thread T, in the ZIO, but that's not actually that useful, right?
I mean, that's why like we kind of suggested PID as one of the options of like using that as
the
the
problem
tag.
is, and this is one of the most important lessons that we had early on at dtrace. Whenever you think of, I want what you didn't think of.
I know, exactly.
Yeah.
So
I mean,
I want an exec name, and how do I get from Ben to exec name?
exactly.
It's almost
Ideally,
like
we
you
would
want-
want all of them. We're trying to figure out like, as we start to kind of build something, what's that first point that gets us?
It's almost like you
something
want
usable?
like the equivalent of this.
Yeah.
Where it's like, I want, the whole namespace of, this and like any local variables that I set to be able to get, pulled into this other context where I'm eventually doing work that was, originally on behalf of this guy's request, so that, when you do the write, you could use dtrace to say, oh, save away some information about extra tags about this write, and then somehow, when I'm doing the ZIO, we give you a pointer to that bundle of information that you saved.
Well, and you have that with associative arrays, right? So you're very close. If I can somehow just associate the tag that we ultimately associated with this with the context that's inducing it, then you give it to me. That's all I need.
So one of the key things here is that when I go from an operation that, for example, is very asynchronous or breaks out into a whole bunch of other operations, right? If I need more than just the originating tag, right? I do need a way to correlate those.
But so what I would say is that as long as you've got a point of instrumentation, wherever that can fragment, as long as I've got a point of instrumentation that says this tag is now these 5 other tags.
So like, for example, if we had something where it's like,
exactly
we had something that's like debuffed dirty probe, a debuffed dirty probe that fires in the context of the guy who's doing the write system call, that passes as an argument some tag.
Yep.
And then in the ZIO write created probe, you pass that same tag there.
Yes.
Then you could use associative arrays to save whatever information you need and pass it from one
and then
context to
you
the
put
other.
the heavy lift on the script
Yeah.
to actually go figure
All
it
right,
out.
that's a great idea. Then we kind of have a laundry list here of all of information that we would need to provide in the ZIO probes.
Sorry, that's a question.
Sorry.
Just 3 quick ones to add, and I can take this offline. I don't see IO size in the list.
Yeah, sorry, some of these things kind of go without saying.
Yeah.
Okay, right, fine. Birth time, if you've already added it.
Yeah, if you're
and,
reading.
Whether it's prefetch.
Yeah, prefetch.
I think prefetch we had,
Thought
but
we had
maybe
that, but yeah.
it didn't make it on our list.
But it looks really good.
It was on the whiteboard, it didn't make it onto the document. But yeah, so we want to be able to slice and dice it in these ways that aren't available in the IO provider. For example, there's kind of 3 different paths that you can get for reading data. One is like a user-initiated, like read system call or other system call, versus like a scrub, versus like a ZFS send, are all very different IO paths for generating reads. And so like the IO provider, even if we could associate the file name with that scrub IO, it would be very confusing to see like, oh, geez, why are all these files being read? I don't understand why you're reading all these random files off my disk. And then performance critical things like, is this a read, or is this a write to the ZIL, including like a DMU synced write where we aren't writing ZIL data, we're writing like what looks like normal user data, but it's actually a synchronous write because it's from the DMU sync where we're writing the data to the final resting place from open context to then reference it in the ZIL.
Are you do ARC probes as well?
Yeah.
I just remember.
Yeah, so we kind of broke it up into 3 sections. We figured like the ZIO pipeline,
Yep.
what we're calling like the transaction engine,
Yep.
and then stuff in the ARC. And we know there's more, but we thought this would kind of be like,
Right on.
So it may be obvious, but the error status for ZIO.
Yeah, so like when that ZIO done probe fires, then provide the error status. Yeah. So we mentioned that we want to provide pipeline stages as we work through the pipeline. So like the ZIO creation and then so on. And this document is linked off of the schedule page. So so then another kind of pipeline of things happening is in the transaction group syncing. So we want to track transaction group state changes and why those state changes happen. So transaction group goes from like being open, where it's accepting new changes, quiescing, where it's waiting for those changes to finish up, syncing, where it's writing out those changes, and then done. And then there's also can be like waiting stages in between those. And then we want to tell why. So why did it transition from open to quiescing? Was it because you know, every 1 second timer fired and said, oh, okay, you've been open for 1 second, great, time to close you off. That probably means that system is happy, performance is good, everything's great. But then if it goes from open to quiescing because of, say, there's a dirty throttle or memory throttle, meaning that we have too much dirty data, then it begins to raise questions of like, oh, like, are we running out of memory in the system? Are we running out of I/O capacity? So these could be used to diagnose more systemic problems that like we already kind of know what's going on because ZFS is paying attention to all this stuff. So just exposing it in a, you know, through a stable provider for people to consume.
That's awesome.
And then within the sync phase of the there's many different parts of that. So the first pass where we're actually generating the IOs and issuing the IOs to the disk to write out the bulk of the data, then waiting for this to complete. And then we have like another phase where we do the scanning, where we're doing scrubbing or whatever, and then issuing sync tasks, which are usually like administrative action related things like create a snapshot, delete a snapshot, create a data set, change a ZFS property. So whenever you're doing like ZFS set, ZFS create, stuff like that.
Before you ask Brian, even freeing like dedupe blocks, that'll be in there.
Dedupe is out of my life, so dedupe and I have got amicable divorce. That's already amicable now. Restraining order. This is going to. Whenever you see the ARC probes, I just visualize the terrible enabling that Schrock helped me write about getting the bonus buffer out to fish the file name from the.
Oh yeah, it's like, hey, if you're an OT ZFS, then I just know this is a XenoT star.
So that's one of the options that we could do to figure out the name there is to like, you know, crawl through all those pointers to eventually get back up to the vnode if it is still there. Which is certainly an option.
Well, we put that into the prison.
With the bonus buffer, have you thought about like, sometimes we kind of store data in there. Do we care about modeling? Because that's just going to appear as metadata. Do we care? Like, do we want
what user data? What
like,
do we store?
Symlinks. So what happens like?
Yeah. I don't know anybody that has a Symlink performance problem, but it's possible.
Well, I'm just wondering, like, do you theorize other uses of bonus buffer?
Yeah.
I'm sure we're not the only ones. So it's kind of like extra space.
I think we
I'm
would.
not sure we do care. I'm just wondering, like, if you.
It is bonus buffer.
I think
It's bonus.
it's a bonus. You get it for free. No, I think that we would want to trace that as probably, you know, we talked about having a probe that fires when you dirty certain data. We would probably want to have that fire when we dirty bonus buffers as well. And so then you'd be able to see like, oh, you know, I dirtied this bonus buffer. Normally that would just be because like we're updating the A time on the file or we're updating the file size. But if you were using it for some other reason, then you know, you'd be able to see that happening as well.
Sorry, we haven't got to ARC yet. I want to ask.
Yeah, I've got stuff I want to put on ARC.
Okay, let's move on to that. For the ARC probes, I think this is kind of where we're least sure what we think is going to be useful. Obviously, I think we want to expose like the global ARC variable state where it just tells you like how big is the ARC trying to be, how big is it actually, how big is the MFU versus MRU. And I think we also want to expose buffer state changes so that you can see you can get probes firing that tell you the state changes between like a buffer was instantiated, in other words, we read it in, or we wrote it, actually, it would get in there as well. And then change from like MRU, most recently used, to MFU, the most frequently used, and then finally when it gets evicted, and then when it's evicted, we actually still track the arc buff header in what we call the ghost list, which helps us to inform the relative sizes of the MRU versus MFU. And then the eventual either from being the ghost list, it could come back to MFU, or it could be finally actually totally destroyed.
So the things that I know that we've struggled with have been really around the reclaims. What we've seen in some systems with actually a lot of print rate, huge arcs, is that when the reclaim does actually occur, we get a huge number, a storm of cross calls, right? Because now you're
Reclaim being
You're
eviction,
saying when they're
right?
evicting.
Yeah.
When it's like going in and like.
Yeah, when it's
came
going,
in.
it's going.
You spend, you know.
So we have to size down all the reclaims. So anything we can do to observe that better
Yeah.
is definitely a win.
Yeah,
Yeah,
so-
I was thinking the same. I know we've had issues where like the arc is shrinking and we don't know why.
Yeah.
So, like, actually,
So I think we want to also like fire probes when the arc sizes change, right? Like when it goes from big and we're like, oh, we just realized that we need to shrink the arc. Fire probe, so we need to figure out why.
Yes, the trigger event. What caused this?
Yeah. Yeah, I mean certainly the stack, but I think that we can narrow that down further with an argument to the probe.
It's the arc came in reap now. It's when it's reaping itself because it can cause issues.
All right. You got that.
This looks great.
Looks good.
Cool.
Bill, where does your I/O throttle fit into this? Or doesn't it?
I have just static probes in the kernel that we have in our gate, which would sort of fit in most logically in the ZIO layer. It could be additional probes that fire that this particular I/O has been throttled, and have the duration that it's going to be throttled as well.
So that would be like one of the pipeline stages,
Exactly.
pretty much.
Yeah.
So I just want to live long enough to see Brendan do a visualization of the ZIO pipeline scoreboard.
like 6 dimensions.
Yeah.
That would be really sweet.
I feel that
Looking
I
out-
feel that I'm not going to understand the ZIO pipeline until we got these probes and that visualization.
Or after.
And probably not.
One thing that might be
I
interesting to collect.
sent a blog post from Brendan coming on in.
So one thing that might be interesting, sort of like we're talking about the language features, is try and collect like questions people want to ask. Like I think there's some very, things about like why reclaims are happening, but even
Yeah.
higher level things that are like,
Okay, so
what is the cost of like SHA 256? Like,
Yeah.
I changed the record size. Like, what effect could that have? And some of that is observed at the app level, which is
Yeah.
ultimately where you should do it. But it'd be interesting to know, like,
Yeah.
what are the things that
I think
people
that
wanna
the
ask.
pipeline-like things, like the ZIO pipeline and the TXT sync pipeline, they fall right into what people have talked about with other, like the HTTP web backend pipelines, where we need to just instrument each stage so that we can see, oh, this stage of the pipeline is now taking twice as
one of the most
long.
obvious things that needs serious work on instrumentation is the snap allocators. We've got a number of different allocators which have been proposed. We've made wholesale changes to the ZFS allocators in recent years. And to be perfectly honest, our experience pretty much is that they pretty much suck in a lot of cases. They suck because the choices that we've made, we haven't documented very well, and it's a case of, courses. It would be really nice to actually have the tools available to be able to kind of say, here's a direct comparison between, very much like Eric's talking about.
Yeah, I mean, definitely that would be part of the ZIO pipeline, because even the cases where we want to be able to see, are we spending a lot of time going off and reading space maps because we can't find, contiguous blocks.
Yeah.
It's
So
like-
I'm thinking of the corner cases when we get into a situation where it's difficult to allocate, and we've seen that the basic choices that we've made have improved things tremendously in the 70 to 80 to 90% range, but then they're pathological once you get over 90%. They really are.
Yeah, the transition between slab
It's night and day.
So. The other thing I wonder is, should we be doing something here to capture dedupe in particular, right?
I mean, a lot of that's going to be captured in the pipeline,
Yeah.
like dedupe itself, because you're going to be able to see cases where you're actually doing a bunch of random reads as a result of, an operation.
But
And
I'm
then-
thinking of it specifically that the dedupe has occurred. Or
Yeah, I think-
I'm not sure how that.
So-
You'd be able to see that.
It's specifically related to the DDT, right? If you want to
Yeah.
instrument the DDT specifically.
I think what we wanted to do was we purposely left this small and picked 3 larger areas because we knew that these were critical.
Yeah.
We recognized that, like, you know, we even talked about, like, well, it'd be interesting to see probes when, you know, you take snapshots or something in the DSL layer, or even as high as DPL. But we figured that this will be our starting point, and I think should open up to, like, specific things like, I want to know how big my DDT is all the time. In particular, when you start thinking about the ARC, it's like, how do I know that I need to up my metadata limit?
Yep.
You know, do I have enough metadata? Am I using enough of my ARC for metadata versus data? What's my threshold? And obviously in dedupe that's important. But
so given that we kind of are hard loss in the room, and I want to get to the BSD and to Jared, I would say that let's follow up on over drinks and when we're not doing more stories. But this looks terrific, guys.
Thanks. And you know, definitely send us some emails about, like, if you have ideas of how you would like to use this that haven't been covered here. And like, let's make this a community collaboration. I don't know, like, how much time we're gonna have to spend on this in the short term. So if other people are interested in working on this, let us know, and we'd be happy to mentor or work with you.
Yeah.
I was asking Brian the same thing. Like, what is the canonical space for dtrace collaboration these days? I'm kind of looking at Brendan.
Yeah, Brendan, where
like,
do you say the wiki is?
Dtrace wiki, and it's kind of, there's like 7 of them, and none of the ones I'd expect.
Which dtrace wiki?
We're asking you to pick one.
Yeah. Like, which is the one where
we need you to bless a wiki.
Developer-oriented collaborative efforts are.
I guess that would now that would be the Illumos wiki.
Okay.
But,
But
if we don't create one on dtrace.org, which we should.
Should we create one on dtrace.org and we can talk about that? All right, we'll hide it in dtrace.org.
We could call it dtrace.
Sure. Actually, the Illumos one does not show up in Google.
Yes.
Yeah.
Okay, it will be dtrace.org.
Dtrace.org.
Dtrace.org/wiki.
Will that be written?
Okay. I mean, we've had a bunch of things that have benefits, so we prioritize that.
Yeah. Yeah, we will. That will. Are you looking at me as the IT organization for dtrace.org?
It makes sense.
All right, take it away.